It's not often that you're able to sit down and chat with a world-leading subject matter expert in any given topic, let alone a topic that's very close to your heart. And on this week's episode of the AI Builders podcast, I had such privilege. I was able to sit down and chat with Max Kanat-Alexander, who is the world-leading expert when it comes to developer productivity and measurement. Max has a CV only most of us can only dream of. He's been a senior engineer at Google, principal engineer at LinkedIn, and now he serves as Executive Distinguished Engineer for Developer Experience at Capital One, where he is the one helping set and drive the developer experience strategy for 14,000 Capital One technologists. Max has literally written the playbook for developer productivity and measurement. He's co-authored 2 books, Code Simplicity and Understanding Software. And on this week's episode, we dive into a lot of different topics, including how the role of developer experience is changing with AI, and why the feedback loop is the most important factor in enabling a true AI native engineering lifecycle. So I really hope you enjoyed this episode as much as I did. So sit back, enjoy the listen. How would you help people? What advice would you give to leaders right now trying to understand how to build an effective way to measure developer productivity? And what are some of the pitfalls that you see that companies kind of lean into, and some of the things that they get catastrophically wrong?
Great question. So I've dedicated a lot of my career to understanding how to understand developer experience. And you know, there's so many things to know in this space. So I wrote a set of documents. Me and my coworker Grant Jenks at LinkedIn, we wrote a set of documents called the LinkedIn Developer Productivity and Happiness Framework. And what that goes over really is not just like what you should measure, but really how to think about measuring. Because I think the biggest thing that people trip up on is they don't think about what their goals are first. And the reality is that what you want to measure is going to be different depending on your goals. Like if anybody tells me their goals and then they tell me the specifics of how their company works, I can tell you, oh, you know, here's how to measure that. Here's how to measure your success at achieving your goals. But the reality is that at any given time, any business is in a different position from any other business. Like maybe the ideal state of the software development lifecycle and software engineering is the same, but that's not the state that most businesses are in. In fact, no businesses are in an ideal state. And they're all in some different state with a different set of problems that they currently care the most about. And so the biggest danger is like you just take some set of ideas that are off the shelf ideas and you try to apply them to your business without deeply understanding why you're applying them. I would say that's the number one mistake that I see. And then probably the number 2 mistake that I see is trying to believing that you can solve everything with a single number. That like, hey, if I just measure PRs per engineer, then that will tell me everything that I need to know. Or people who are on the other side who are like, this single number is always bad. Like people who are like, you should never do anything with PRs per engineer and it's totally useless and don't look at it at all. Well, the truth is somewhere in the middle of those 2 things. Like PRs per engineer is one of your signals. You might also care about things like if you have a way of figuring out, for example, reliably how many actual defects are getting into production, and how you would do that, by the way, totally unique to every business, totally unique. If you have a way of correlating some of these things with like how much negative customer feedback do I get after I do releases, as an example, like that, but that, you know, that tells you about different things also. You have to, it's so much about understanding. Like fundamentally, it's about understanding how to understand. And ultimately what you want is you want to be able to triangulate from multiple pieces of data and then seek the truth.
And in your experience, in my experience, right, when I come to trying to design these systems, I get some upfront resistance from engineers because they think, okay, you know, you're threatening my livelihood here. I'm trying to build beautiful software and you're trying to like metricize it, right? And you know, almost they see it firsthand from the stick approach rather than the carrot. And as you mentioned, like it's a signal
it's a point in time, right? And it's helping people like figure out what that point in time is and course correct. So like, how would you, what advice would you give me and maybe other people listening to approach engineers and getting buy-in for this?
Great question. One of the most important messages that a business needs to deliver about these metrics is the reason we have these is to improve your developer experience. And everything about how you design the metric, everything about how you display it in the dashboard needs to make it extremely clear that it's not there to measure or be used for individual performance. And because there's multiple reasons not to do that. One, yeah, developers don't like it, but like even for you, the team that is trying to make change in the company, there's a really good reason not to do that, which is that it creates perverse incentives. Like, like let's take our PRs per engineer example. This is one of the easiest ones to do. If you, the company, say we're going to do performance management entirely by PRs per engineer, which nobody should do, then what happens is people start splitting up PRs in unnecessary ways. They start sending out garbage, nonsense PRs. They start sending out PRs that like make one typo and then fix one typo. Like, and you count it, and then they look great. But the problem is, all of a sudden, your metric becomes meaningless. Your metric is no longer useful for you to understand things like, hey, we released a new developer tool. How did it affect teams? Because that's really useful. Like as a person who helps lead a developer experience team, that's data that I absolutely need to understand the success of my thing and also to understand the problems that I need to go solve. So if I create perverse incentives in a business to behave in unnatural ways, then what I do is I actually defeat the whole value of my metric.
Yeah. And it's very easy to add even more metrics, right? And like, I think I've been in situations before, meetings where other team members or leaders come in and they want to add even more metrics because they think that more metrics is good. But it's like a good UI, right? Sometimes you need to remove things, right? Not add things. So how would you, the person who's in charge of this and gatekeeping this, how would you get them to think about like adding new metrics versus actually taking away metrics?
Great question. Everything always goes back to what is your goal?
Right.
And does adding more metrics help you seek the truth that gives you the goal that you want? Or does adding more metrics just happen because you think you should have more metrics? Like this is a very difficult space. To be clear, developer experience metrics is the single hardest problem in developer experience. And so the fact that people get this wrong, nobody should feel bad about it. Yeah. Everybody gets it wrong all over the place. Even in the most advanced technology companies in the world, we all learn over time.
Yeah.
But the thing you want to watch out for is just somebody's like, well, we should measure widgets per second because we should measure widgets per second.
Yeah.
And it's really that like because that you need to have for every metric. And if you have that, you're good. But then it also lets you think about how would I design the UI? So if my goal is I want to understand quality, then you're like, oh, okay, but first of all, what aspect of quality? Okay, well, how many bugs are getting through our initial tests? Okay, well, then how would I measure that? Well, I'd measure maybe like how many things the later stages are detecting, right? And then I'd maybe figure out how would I categorize those? Okay, how do I categorize those? And can I categorize them in some way that lets me know these are things that earlier tests could catch and these are things that earlier tests couldn't catch? And then I want a dashboard that's just about that. And I think a really key thing to understand here too about all metrics is metrics are not the truth. Metrics are just points of data. And they are not a whole story all by themselves. And they are also always a proxy, and they are always imperfect. And so you're always like, you're never going to have a dashboard that's like, here's the dashboard that tells you the whole truth. There is no such thing. But what you can have is a dashboard that gives me the insights or shows me the problems or shows me where I need to go seek the truth.
Yes.
And so if you think about that in your mind, that can guide both how you structure the UI and what metrics you want to build.
Yeah, yeah. I guess, as you said, right, it all tends to go back to your North Star metric, your business goal, your KPI. What is the business outcome, and why do you need to measure this, and why does that relate to the business outcome? What I've seen is that some people just take the easiest route. This is easy to measure, so we should just measure it, rather than actually being very critical and saying, okay, maybe we don't measure that because it doesn't actually bring us to that North Star metric, and it doesn't create the right behavior, which is what I like from when I read your piece. I was like, okay, this makes a lot of sense, because both business people and technical people can understand this, and it's aligning people to the goal and, reducing the drift, I guess.
Totally.
How are you seeing this evolve with AI?
Great question. Today, there's a lot of interest in like, how do you measure the success of AI adoption or AI tooling? I think probably the company that's the most well known for doing work in this space is DevEx. Today, they publish some really great reports, and of course, the DORA research organization publishes some really great reports in this area. And mostly what I see has changed is there's a lot of interest in the correlation. There's a lot of interest in like, what types of AI data correlate to what outcomes. But the interesting thing is the outcomes that we care about haven't changed. And I would say one of the biggest themes that I've learned in the last year is that what AI changes about the software development lifecycle is nothing other than how you do it.
Yeah. So when you said the types of AI data, can you double click on that?
Sure. So there's been lots of different attempts in this space. People have counted, like back to the days of Copilot, people counted the number of autocomplete suggestions that you saw. They counted the number of chat prompts you sent. Nowadays they might count the number of, like, if you're using Windsurf, they might count the number of tokens you use, a number of credits you use for credit-based systems. For token-based systems, they might count, some teams have been looking into token usage, not as like a absolute number, but just as like is there some breakpoint where you see like, hey, this person's engaging? I think what people really care about the most that I see today is, are developers deeply engaging with AI when they do the work of software development? Because it's also important to remember, developers do not do the work of software development all day. They have many other tasks that take up their day. So the key question people are mostly trying to answer is, at the time that a developer is developing software, are they doing it by deeply engaging with AI? And then I think another question people have is the skill level of people using AI advancing over time or not? These are both very hard questions to answer. And just like all other questions in every field, quantitative metrics are a proxy for them. They are a thing that like we can look at, and then we can check the ground truth of. So we can say like, hey, we looked at these bands of token usage, and then we went and we talked to these developers, or we watched them, like we got their permission and we sat behind their shoulders for a little while, and we said, can we watch you work? And then we watched them work, and we said, yeah, this person looks like an active token, like an active AI user who really understands what they're doing, and that correlates to these metrics. So for now, we'll measure these. One of the challenges is the tooling space is changing so rapidly. That the data that the tools emit could change pretty dramatically over time. Like you could get a new upgrade of Claude Code or Codex or whatever that like uses dramatically more or fewer tokens because of changes that were made to the agent itself, to skills that it has installed, to the model, or any such things. Like the number of chat prompts could change, the number of tokens in chat prompts could change. So it's a much more rapidly evolving field than we've ever had to deal with before. But it's very similar to other developer experience tooling questions that we've had in the past, which is, how does interaction with this tool affect our other metrics?
It's just taking one step back, right? What you're describing, I've had so many conversations over the last 2 weeks, right, based like on this, and you're right. Like, the first part is like, okay, my developers don't use AI. I need to get to using AI. And we're measuring those proxies, output tokens being probably the most popular, or seeing a shift in the lines of code, which for the record, I don't see as a good measure of anything, but it's a proxy, right, of who's actually shipping more lines of code. And they identified our power users. And then once they've identified our power users, they're then trying like, okay, we kind of understand what the playbook looks like for a power user. And as you said, right, as they're developing software, how are they using? Are they developing skills? Have they multiple trees? Are they, are they using Cursor, Claude, in what variants, right? And then from there, then that's when they try to standardize it to their normal metrics, right? Is that kind of like, I guess where I'm getting to is there's some people at different levels, right? And some people are kind of balking. It's like, oh, I'm left behind. If I don't actually up the ante or measure lines of code, and they're being maybe pushed to measure lines of code as the proxy for management, and they're trying to report upwards and maybe set the false expectations versus people who are further along. Like, what advice would you give to people in terms of on their journey, and at what point would you tell them to flip the switch and say, okay, you've got now a good understanding. Now it's trying, okay, like less about lines of code or those signals and proxies, and actually more about, okay, how do we make this work systematically for the organization?
Yeah, your focus should always be on how do I help my developers the most. And I think it's very easy to lose sight of how do I help my developers the most, and just look at one single number somewhere in a graph. With things like token usage, for example, it's very important to remember that tokens are a cost.
Yeah.
Like, you don't actually want to drive up cost. So the one thing you don't want to do is, it's just like the conversation we had about perverse incentives about PRs per engineers.
Mm-hmm.
You definitely don't want to tell your developers use more tokens. That's not a message you want people to hear.
Because they will.
they will, especially if you tell them that it's somehow tied to their performance management,
Yeah.
which once again you should not do.
Yeah.
Like, I've heard stories elsewhere in the industry of teams just like spinning up, like individuals just spinning up background jobs that just basically like waste tokens, and that just send like a test message over and over to the model, just so that they can be seen as high token users. That's obviously not behavior that I would encourage, and but also like not behavior you should incentivize. That's the idea, right? I think what I would say is, it all goes back to the same thing. You should understand why. In this case, why is we want to ensure that we're improving the efficiency, effectiveness, and happiness of developers. And the reason you should want to do that is that you should have a thesis that improving the way that we do software development is an important part of how we produce results in our business. It is very dangerous to somebody show up and be like, can you just correlate everything to our revenue, to our gross revenue? And the answer is no. By the way, no. The answer is no. But people who are asking that sometimes are not thinking through the fact that a business has many components. And one of those components is the process through which you get results. It's not like a business is not just the end result. It is also it is a giant machine that produces the result. And so how that machine is functioning is important. You can certainly make a car go that is broken by pushing it, but you probably shouldn't. You should probably understand how the car works and make it actually function by like doing an oil change and giving it some gas now and again. And so even though the reason you're putting gas in the car and the reason you're doing mechanical tune-ups is to get to a destination to drive a car, those are still really critical points of driving the car. And so I think it's really important. So first of all, you got to come with that attitude. You got to come with the attitude of, fundamentally, optimizing our developer experience is important. If it wasn't, we wouldn't employ software engineers. Like there's really only two options to have there. Either you employ software engineers and optimizing them is important, or you don't employ software engineers. Then you should have this thesis, like, we believe that AI tools are the most powerful accelerant that we've ever seen potentially in the history of software engineering. That is, I believe, my opinion is that that is true. That they are potentially the greatest accelerant anybody has ever experienced in the history of software engineering. So then your question is, how does that acceleration happen? And this is the leap that most people fail to make. Like, what is it that actually causes that acceleration? And generally, I'll tell you what causes that acceleration is deeply understanding how to do this new thing, just like it is with any other technology. Like when you saw developers in the past who were individually very productive, what you didn't see was years and years of learning how to do that behind that. And what people don't see with people who are very productive with the agents is a lot of time spent learning how to do it. So, so what you want to, so you care about, did you allow for the process to occur? Like, are people ramping up? Are they engaging with it in a way that indicates that they're learning, first of all, even if their productivity isn't increasing? Are they learning? Because that's what's hopefully going to give us productivity in the future. And then two, once they get to that active state, what are the, like that very productive state with it, what are the signals that you get from the developers who are the most productive with it? What are the patterns that you can see in data from the developers who are the most productive with those tools in your organization? And while we could certainly talk about things like token usage or prompts or whatever, there might also be signals that are unique to your business. There might be other tooling interactions that they have that show you that, like, oh, like this is actually, or if we triangulate these three signals that are actually specific to our development environment, that gives us the full picture. And so it's not just like, what do I measure? It's the whole process of figuring out, how do I measure it?
I really like that. I really like that. And I guess the next level to that is like, okay, we have power users and we're understanding the pattern. How do we translate this knowledge to everybody, right? Because, it's like a normal distribution curve, right? With it, you've got your top 10% of developers who are using probably 90 or 80% of the AI tokens that you see, right? And then there's the rest of the organization. And, some engineers there might be some stigma with using AI. Maybe it's just the system they're operating in, they're getting better results by just hand coding. And that's some nuanced discovery that you have to do as well. But in general, how do you translate this? How do you educate? Like, what are the best practices in sharing this knowledge to the rest of the development team and showing them that there is a path?
Yeah, such a great question. When I talk about what makes a great developer, I say that there's three components of what makes a great developer: awareness, understanding, and responsibility. And I think when we talk about AI tools, the thing that matters the most here is awareness and understanding. So at first, your problem is purely awareness. People who are resistive, I find most often, are simply not really aware of the tool. They may have messed around with it once or twice, but they have not really deeply engaged with it for long enough to be able to feel and experience the power and freedom and capability that it gives them. And so one of the things that I've seen work is set aside some time for the whole team to do a workshop using one of these tools, like Claude Code or Codex or Cursor or whatever agent you think is like a really high capability agent, right? Not just an autocomplete system, but like something that like really has like very strong agentic power. And first of all, like, go over the basics, tell them about context windows, tell them about, context rot, and like tell them about planning if you think people should do planning mode and whatever like that. Just there's like the basics of like, just tell them about the basics. But then have them do something that is both easy, fun, and magical with it. Run them through an exercise. Like an exercise that I've run with some folks that I think is really fun is have them build a clone of the game Rogue, like the text-based game from give them a short little spec for Rogue, like not long, with like an incomplete spec. Give them an incomplete spec for Rogue, and then tell them, give this spec to your agent, and then have a conversation with it, and go and make a plan, have it make a plan, and then have it implement it. And I don't even get too deep on like you should do the code reviews with it at this point, because like, look, realistically, my belief is that especially if you're in a company inside of a business, you still need to be looking at code. Like I know that people say otherwise, but my belief is that like if you ship things to your customers that you care about that are going to be long-term maintained pieces of software, you really need to be looking at code today. I always do with the agent that I work with. But in this exercise, I mostly don't have people focus on that, because most of what I'm trying to do is get them to feel the magic and have fun. And because when you go back to it, if you ask every software developer, why are they a software developer? Once upon a time, they had a magical experience. And that magical experience was, I told the computer to do something and it did it. Every single software engineer in the world has had this experience at some point. They were like, wow, this was incredible. That experience is magnified tenfold with agentic engineering. And so if you give people that magical experience, they will want to keep having it. And so that's how you get over the like basic resistance barrier of like, oh, this thing is garbage, is don't have them work on it on a project where it's going to conflict with like their judgment and expertise, where like they feel threatened by it because like they've spent so much of their time building up their identity as the person who understands this code base. Have them do it with something fun. And like the roguelike exercise is really fun. Like people make all sorts of different ones. They get to express some creativity. They use different colors. They make different themes. They do it in different programming languages. And then you can have everybody show off to everybody else and then talk about their experience. And it's all just like a big learning experience. It's all just like, hey, get everybody together in the room, have fun. So that's the like, how do I get over the basic resistance aspect of it? And then how do I build understanding? I don't have a perfect answer for that, but what I tell teams today is every engineering leader needs to tell their teams, this is a time of learning. And when we initially adopt this, there might be a decrease in productivity, and we should expect that. All the research that I've seen shows a decrease in productivity from initial adoption of agentic development, which will get better over time. It will eventually dramatically accelerate you. But all leaders, all engineering managers, I think, need to understand that this is a time to make space for their teams to learn and to say, hey, it's okay to spend a few more hours on this task today, to mess around with the agent, to learn its capabilities, to try different ways of doing it. Especially because one of the most amazing things that I find personally about agentic software engineering is it's so much easier to just throw away a big mistake. Yeah. Like I've spent like an hour on something that's generated like 500 lines of code and just been like, nah, this is wrong. And I've literally just thrown away the whole thing, which something that I would have never done before. And that message has to be given to IC software engineers by their managers. It cannot be implied. It must be explicit. Like, it is okay to learn. It is okay to slow down a little bit and take this time to learn now, because that is the only way that you will accelerate in the future. And my opinion is that if you do not do that now, you will be dramatically behind in the future.
Amen to that. And what advice would you give to software managers or engineering managers, right? Because I had head of engineering at another company, and he was saying, like, we're still figuring this out, right? And you can lead from the front or lead from the back, right? Like, what advice would you give to engineering managers who might have not touched code in 5, 10, 15 years?
Here's what I would say. A lot of this depends on your current, like what you should do depends on your current confidence and your technical skills, I would say.
Right.
But everybody should try to engage with the tool. Everybody should understand it. If you still feel like you have deep technical skills, then I would encourage, especially frontline engineering managers, to get a little more involved in contributing directly with the team here and there, because it is easier than it was in the past. Now, I will say it still takes focus time. I still need hours of time to get serious work done.
Yeah.
If I want to be sure that I'm producing high quality software. So you should not expect that you're going to be doing serious work in like half-hour snippets throughout the day. The best usage of it for leaders is prototyping, experimentation, and tools for yourself.
Yeah.
You can build almost anything you want to be used by you in a relatively short period of time, because those things don't require code quality. They don't require perfect functionality. And prototypes are the same. You can build a prototype of anything if you are having a hard time like explaining to a team what you want. If you're not, if you have an idea but you're just not sure it's going to work, you can prototype it yourself. And that's today where I see the best use of AI by engineering leaders across companies today.
And you're increasing your credibility, right? You know, you're not telling people go do something that you haven't done and don't have a first-hand experience of it, right? Which I think is super important today.
Yeah. And it's also super important because it really is a different world. Like the fundamentals of software engineering haven't changed, but how you do it has changed dramatically. And if you don't understand that as an engineering leader, if you don't have like a personal understanding of it by having actually like done this work yourself, you will make decisions that are not optimal.
Yeah. So we've kind of talked about the foundation, right? We've talked about, you know, how we get people enabled and maybe like carry that forward. And I've seen AI accelerating the output, right? But it's create bottlenecks elsewhere, right? And I've seen the risk profile of software changing, right? And so like I maybe we can double click on that. Like, what are you seeing in terms of the overall pipeline? And is it changing that dramatically than we think, and is the risk profile changing? Like, how are you seeing that?
All these things are changing differently for everybody. And I think the biggest determinant of how it changes is, well, there's probably two. One of them is, how are your human processes set up at your company? And two is, what is the state of your developer environment? Like every part of the environment across the software development lifecycle. So I'll start with the last one. Teams where there's been a really heavy investment in great testing, great high quality testing, great static analysis tools, a lot of automated protections, a lot of automated guardrails that simplify the lives of developers as opposed to just being things that stop them from doing what they need to do. Like where people have really, really invested deeply into the fundamentals of developer experience, not just shipping agents to people. Those are the teams that see the best acceleration while developers are writing software. During the time when developers are writing software, teams that have invested deeply into the fundamentals of developer experience, all the things that we have always needed to be done, are the teams that see the greatest lift today from AI. But remember, I said while they are doing software development. And so the thing you have to realize is that across the industry, developers spend somewhere around 20% of their time doing software development. And it's worth looking into in your company where that other time is going. And my experience is you don't solve that purely by just mandating that everybody should be writing software all the time. You solve it by doing an investigation into why they aren't. And you will find a lot of very interesting things. Like you can find processes that need to be adjusted or that are out of date or that should be replaced by automation. You'll find expectations that people have about what their job is or who should be approving things that are not what you think are supposed to be the case. You can discover all sorts of things. You can discover that, there's some confusion about requirements. You can discover that there's something going on with the product development process, like the research side, or customer feedback, or customer support. I mean, there's so many different things you could discover that I can't tell you what they will all be, but it's really, really worth more than ever diving into all those things that happen outside of software development to understand how you can optimize that process so that developers can spend the time that they need to focusing on software development. And I want to caveat that's never going to be 100% of the time. Because if you said 100% of the time, you'd be assuming that nobody ever talks to anybody, and that no coordination ever happens, and that no planning ever happens. And I hope that that's not the business that you want to build.
No, definitely not. Definitely not. Silos are bad. That's, silos are bad.
Yeah.
Do you think feedback loops will become a developer experience metric, or the signal to correctness, right? Because in my experience, okay, I've got different trees running. Like testing becomes the bottleneck, right? Yes, I can run hundreds of thousands of unit tests, locally, but if I want to do an integration test, or I want to run it on run CI, the feedback loop is 5, 10, maybe an hour, based on like the size of the PR, right? So do we think that like the feedback loop will become a measure of part of the developer experience measures, or do you think that's something that's going to be unique per team that you kind of keep an eye on?
Well, I think it's both, because I think the feedback that you're getting is going to be different depending on how your tooling is set up. But I think that's super important. And in particular, one of the things I think has become even more important than it ever was is having as much feedback as you can at development time, so that the agent can experience it.
Yeah.
Like, there's a lot of people who I've seen where like their software development lifecycle, all the validation happens only in their continuous integration system after like a 15-minute or an hour-long run.
Yeah.
And that's not going to work for agentic software development. Like, you absolutely must figure out how to move all of those things onto the machine where a developer is writing software. If I had to tell you like the most important thing you need to do to enable agentic software development, it is probably that.
Yeah. It's so funny. I have conversations now with staff engineers and like who are really proud of their CI that they built, right? And it's like, yes, it runs in 15 minutes or half an hour, and now they're like, it's too slow. It is too slow now. It's like, yeah. So yeah, we're seeing shifts in that.
In my side project, I had my full test suite ran in 30 seconds, and I was extremely frustrated with that. Like, I spent time optimizing it to get it down to like 11 seconds, because it made such a difference for my productivity with the agent. Because it runs the tests so many times that like if I don't optimize that, it adds a dramatic amount of time to the waiting that I have for the agent to finish work.
I did the same, man. And you know what I got down to? It was the compile time of Java, which is, a couple of seconds. And that was even frustrating me, right? Compared to maybe TypeScript or Python, right? So it's, like even those milliseconds count, and you can feel it and see it.
I'm familiar with that exact problem. I worked on trying to optimize that problem at Google.
Oh, there you go, man. There you go. So we're kind of still like, well, from what I'm seeing in the market, we're still kind of in this like developer in the loop mode. And, if we hear some of the LLM providers, it's like, okay, it's going to be fully agentic. All software will be written by the LLM, monitored by the LLM, tested by the LLM, etc. And it's like this, almost like the LLM OS for software development. And I do see some projects being fully written end to end and tested end to end with AI, with LLMs without developers, right? But in my chair, I think like human in the loop is going to be here for at least another 12 months, if not longer? Like, what's your take on this? What's your read on that?
That's a great question. So nobody can predict the whole future.
Yeah.
I do not expect the profession of software engineering to vanish from the world ever.
Yes.
I do expect it to change. And I can tell you today where my input is the most necessary in the agents. And it is process, judgment, and expertise. So the thing today that the agents are the worst at is figuring out the process required to get the correct result. They are very good at take this chunk of work and do this chunk of work that is self-contained where I can predictably see the end result. With a multi-agent system, you can get further. You can do a little bit of like, here's this larger thing, break it down into a set of tasks. But even then, one of the problems that it has is it often doesn't understand the process of engineering required to get to a result that is not known when you start. Like if you are empirically building an algorithm by doing experiments over time, as an example, the agent is very bad at that today. I have specific problems. I have like one specific problem that I am working on in the outside world that I have tried multiple times to get the agent to do that I actually have to do by hand. There is one thing still left in the world where I must do it by hand, like entirely from end to end, and no model has yet been able to do it at all. And the reason is the models can't figure out the process to go from like, here's a series of things to do to get to a result that we don't know what the result is. They're really great today at like, I know what result I want, deliver this result. But they're not good at like, here's a process by which you will build or cause to build, exist an unknown result. And at scale, all results are unknown.
So you're talking about the halting problem, like the mathematical theory of the halting problem?
I mean, you could think of it that way, but
Right.
I would think of it more as like a human problem that you have where you're like, if I could tell you the entire implementation and all of the details of my thing, I would have coded it.
Yeah. It'd be quicker to code it, yeah.
Right? So there is a certain amount of like, it is not actually possible for me to tell you the end result. I saw a really great post, I think it was from Scott Hanselman from Microsoft, where he said there's a lot of people who will show you that they can build a clone of Microsoft, of Minecraft. And the reason they can do that is that the word Minecraft is doing all the heavy lifting. That the agent has seen Minecraft and can build Minecraft.
Yeah.
So the closer you are to, I want to duplicate exactly a thing that already exists in the world, and I don't really care about the quality of it, the more the agent can just do everything for you. And the closer you get to, I want to build something that nobody's ever seen before, where the quality of it really matters, the harder it is for the agent to do that by itself. And in particular, the thing that nobody's ever seen before, it doesn't understand the process to build a thing that nobody's ever seen before, because it wants to predict the end result from the input. That's what it wants to be able to do. It wants to be able to know that there is a predictable path from input to output.
Yeah.
And if there is no predictable path from input to output, even if I could describe to you like the process through which a human being would go and make judgments to build that, the agent can't do that by itself. So that's process. And then judgment is another thing that I kind of touched on there, which is today my input is the most necessary, like the most frequently necessary, in that the agent made a decision in implementation that is not the right decision. I think one of the things people most commonly cite today is like a bunch of unnecessary defensive code as an example that will add, or it chose to swallow all the exceptions, or once in a very rare while it still does things like it just wrote to do instead of doing the thing that I told it to do. And So that's where my judgment comes in about like, did you do the right thing? Is this the right way to do this? At a higher level, there's the judgment of, is this functionality the functionality that a human being wants to interact with? Or if I'm the user, is this the functionality that I need? So there's judgment on maintainability. There's judgment on non-functional characteristics like performance, things like that, security. The agent is fine at some of those and it's not fine at others. And you have to have that judgment. And that sort of gets us into the last section, which is expertise. There are areas where my expertise as an engineer are today necessary in order to build software successfully. I would say everything that I work on requires that. Every time that I have abandoned my judgment and expertise to the agent, I have only gotten myself into trouble. And I'm sure that people could say skill issue, but I do spend 4 to 6 hours a day with coding agents on my own personal time. And I have been doing this at least since November. So it's not like I was doing it before the Opus 4.5 revolution that changed the world. And it's not like I don't know what I'm talking about. And it's not like I'm not building real complex software. I'm building some incredibly real, incredibly complex software. Yeah. And it's not like I haven't done a lot of it. So I hear a lot, when I hear those statements from people who are like, I built this thing and I didn't need to look at the code. What I have yet to hear is, I looked at the code and decided I didn't need to look at it.
Mm-hmm. Yeah. Yeah.
Because I do look at the code, and there are currently about 1,000 commits in my project, all from me and Claude and Codex personally in my work outside of Capital One. And I would say that about 4 of those, it did perfectly with no feedback from me at all. Some of them were great. Some of them were amazing and complex and super cool. And I was like super impressed that it did it. Some of them were like hundreds of lines of code, but they were like deterministic transformations. They were like, refactor this thing into this thing in my code base that has like 99% code coverage.
Right. Yeah.
So like, can it do it? Yes. Will it get better at that? Yes. What I expect is this. I expect over time, the agents will become amazing at execution. What I don't know is to what degree they will improve in judgment and the ability to execute a process of engineering successfully.
Okay. I like that. I really like the framework: process, judgment, expertise. Yeah, I really like that.
Thanks.
Yeah. We had some fun internally at Kernel. We built a skill that emulated the judgment of Linus Torvald, the Linux guy, and also Rich Hickey, the founder of Clojure. And, yeah, so Linus was absolutely brutal with some feedback he was giving us. All right, yeah. So
I've had somebody do that too, right? Like Linus has a very particular way of talking.
Yeah,
I think most
exactly.
people would often not consider polite.
Yeah, exactly. It's we just did an offsite in London and we were playing around with it. It's yeah.
That's fun.
Man, I've really enjoyed this so far, right? And I think like we're kind of coming to the home stretch. I kind of ask everybody. This is the last question I'll ask, but I kind of ask everybody the same question. There's information out there, and at times when you're at the coal face, you can be sucked into the weeds and be in an echo chamber, and with that comes like certain biasness and maybe following the crowd and herd mentality and all that. Like, but do you think there's any signals that we're missing that the mainstream hasn't caught on with yet, or is there signals that we should be really paying attention to that maybe you're not seeing enough attention on?
The things that I think are the most interesting, that are the most overlooked. So I think mostly all the attention has been on velocity.
Yeah.
So the attention has been on, we accelerate velocity. I don't think that software is a quantity game.
No.
I think that software is primarily a quality game.
Yes, 100%.
That's true both in the quality of the code and in the quality of the end product that you use as a user. You can definitely overcome some of that with marketing and the power of sales organizations and all that stuff, but it's very, very hard and much easier if you focus on quality. And there's not as much of a story coming out about quality. And I think that's really surprising, because my personal experience is you can build better software than ever before with agents if you choose to do so. It is so much easier to write great tests. It is so much easier to refactor. It is so much easier to experiment than it's ever been before. You should be able to write dramatically better software than you've ever been able to write before. And I really would love to see more stories and more insights into how software is getting better, not just faster.
I love it. I love it. I'm on that train. I'm definitely on that train. Max, I've really enjoyed this. We have covered a lot. I hope our listeners can cherry pick the things that make sense for them right now. I think I would recommend people to hop on your LinkedIn page. There's information there about all the previous writings and current writings. I think you come out with a lot of great thought-provoking pieces, but also deep thinking as well. So I really enjoy some of your work that I've read through in preparation for this podcast. But really enjoyed the chat, Max. And I'm hoping that we'll be able to have some beers in Florida soon.
Thanks, Sean. Would love to do that.
Cool. Bye, Max.
Bye.